What's up, Logic fans? It's Ash again. We're going to cover section 5.4 of the text today. This is our fourth section on quantificational semantics, and here we continue our study of how to present interpretations in a streamlined way, namely the Tableau technique, and we haven't looked at any quantificational sentences involving identity yet, so 5.4 is dedicated to the study of how to do Tableau interpretations for sentences involving identity. Let's rock. So as we'll see, identity Tableau function in a very analogous way to relation Tableau. So we're going to introduce another Tableau for identity statements. So you could have up to 3 sort of tables in one interpretation. You could have one for your property constants, one for your relation constants, and one for identity. And we'll show you some of those examples, but it's not 100% analogous to the relations because identity does end up introducing a few nuances which we have to be attentive to. So I think the best way to introduce you to this is just via example. So I'm going to walk you through this one here, and the idea is to produce a interpretation that makes the sentence true and an interpretation that makes the sentence false. So here's how we're going to do that for sentence 1. So for sentence 1, what we do quite simply is we, if we want to present an interpretation that makes it true, okay, we have a separate identity tableau, which is going to be separate from any relation tableau and separate from any propositional constant tableau, okay? And all you have to do is present the identities that occur in the sentence. Okay, so in this case, there's just the one, so we just need this one guy, and we're going to go ahead and make it true. Okay, now if we want to make it false, it's kind of interesting, but you present a tableau, right? And all you have to do is go ahead and make this false. Now, some students sometimes what they want to do is they want to present the tableau this way, right? And so what they'll do is they'll do that, and then they'll sort of say, oh, okay, I want to make sentence 1 here false, and so they'll write it this way, right? So it's true that A is not identical with B. In other words, this sentence here would be interpreted false by this. Now, there's obviously an intuitive rationale for that, but we're just going to sort of lay it down as standard orthodox operating procedure that you always present the identity in question positively as something is identical with something and never have the negative symbol here. All right. So, and recall back in our work in chapter 4, right, that this symbol here, we can actually write it this way, right? So if you remember in chapter 4, we actually don't need this new symbol. We just need this symbol. And then we can use negation to do this, but we read these as the same thing, okay? All right, so we're always going to present a positive sort of identity symbol here, okay? And then do our interpretations that way. Okay, so based on that, go ahead and pause now and provide me with a Tableau interpretation of sentence 2 that makes it true and a Tableau interpretation of sentence 2 that makes it false. Pause now. Okay, so the first thing you want to do, right, is you want to do for an interpretation that makes it true is you want to have your identity Tableau, all right, and you're going to have the relevant identities. So we're going to have A is identical with B, and we're also going to have B is identical with C. And then, of course, to make it true, we need this one to be true, and we need this one to be false, right? And any other kind of combination is going to make this particular sentence false. So for the false case, you just have to change one of these things. For example, that would do it, right? Because this is a conjunction, and if the left conjunct is false, then the entire conjunction is false. So this behaves in a very, very similar way to the relation tableau that we were introducing in the previous section 5.3. Let's try some more sophisticated examples. In particular, let's look at some examples that we have to mix the identity statements with property constants or with relational constants or with all 3. Okay, so let's take a look at an example like this. We'll get to examples involving quantifiers in a little bit, But let's try some of these ones. So pause now. Can you provide me with an interpretation, a Tableau interpretation that makes sentence 1 true, and a Tableau interpretation that makes sentence 1 false? Pause now. Okay, so to make the interpretation true, right, so I've got it colored in green here as usual, and to go ahead and make this true, if you can think about it a little bit, right, what you're going to have to do is you're going to have, well, there's different things you could do. You're going to have either a false antecedent or else a true consequent, basically, is the idea. So perhaps the simplest thing to do is to make this false, right? Now, notice what I've done here is I've left a blank space here just to sort of separate the property constant Tableau from the identity Tableau, okay? So you'll see that in the textbook as well. But yeah, if I make A lack the property F, then this whole conditional is going to be true, and I can just leave this blank. It doesn't matter what I do with A is identical with B, right? And notice I've got both A and B in my domain, okay? So that's important to list that. So I've got this domain. It's got, you know, let's say 2 objects, depending on what you put here anyways. If this is plus, then it's really just 1 object because A is the same thing as B. But you got 2 individual constants, let's say. And if, you know, FA is false, then the sentence is true. You could also make it true by making this true, but then you would be required to do this, okay? Similarly, right, if we want to make this a false interpretation of sentence 1, then one thing that we have to do is go ahead and make the antecedent true and the consequent false. So this would be our only possibility for this sentence, and that would be an interpretation with an identity Tableau and a property constant that makes sentence 1 false. Okay? All right, go ahead and try this case, which has both an identity and a relation in it. Okay? Pause now. With an interpretation that makes it true and an interpretation that makes it false. Pause now. Okay, so to make sentence 2 true, right, we notice that it's a conjunction, so both conjuncts have to be true, which means we have to have a plus here and we have to have a minus here. Okay, and this is an interpretation that makes sentence 2 true. Notice I've separated the relations from the identity parts of my table by putting a blank there, but you can just present altogether separate tables if you want. That's fine. It just has to be absolutely crystal clear, okay? That's the main requirement. Now, what about if we wanted to make sentence 2 false? So if we were going to make it false, right, then it's a conjunction, so it suffices to make at least one of the conjuncts false. So if I did this and made and left this part blank, this would suffice to make sentence 2 false, right? It's a conjunction. The right conjunct is now false, and therefore the sentence as a whole is false. Okay, now let's try a case that involves property constants, relations, and identity. Go ahead and pause now and provide me with an interpretation according to which sentence 3 is true and an interpretation according to which sentence 3 is false. Okay, so hopefully you've had a chance here. Now we're going to do the one that the interpretation that makes sentence 3 true here and the interpretation that makes sentence 3 false here. So you know, if we want to make it true, it's kind of interesting. All we have to do is ensure that this disjunction is true, and that would mean making the left disjunct true would suffice, right? So that would perhaps be the simplest way to do it. Let's suppose you had made this false, all right? Then you would have to make this disjunction true, and again, there's multiple options there. One thing you could do is make the consequent true, so that would suffice, right? And in fact, if you just had this all by itself, leaving everything else blank, would make the entire disjunction true, right? Because you got a true consequent, which means that the conditional is true, which is the right disjunct. So the whole disjunction would thereby be true, okay? So there's lots of different options for that particular case. What about a case that makes it false? Well, in that case, we need both disjuncts to be false, and so here we're a little bit more constrained. Okay, and notice again, I've got A and B presented as the domain. That's going to be important in the future. So when you do have the property constant table, make sure you list all elements of your domain. Now, we got to make this false, okay, and then we have also got to make the right disjunct false. That can only happen when the antecedent is true and the consequent is false. So we know this part's going to have to be false, but I've got to make RBA false, right? I've got to make it the case that not RBA. So not RBA, right? So that would turn out to make this whole thing true. So if RBA is false, then not RBA is true. So you got true arrow false, which guarantees that this conditional is false. So both disjuncts are false, and therefore the sentence as a whole is false this way. Okay, and that's the basic procedure for how we do identity tableau. So it's just sort of like adding yet another table for identity, but this does actually create some complications that we have to note. Now, one of the complications that emerges once we introduce identity tableau is something that in the text I call failed correspondence. Okay, so here's the overview of it, and then we'll look at some particular examples so you really get the concept. But failed correspondence occurs when in a Tableau interpretation of a sentence involving identity, for example, a sentence like this that has the identity symbol present in it, in that Tableau, the laws of identity are fail in some way. They fail to be observed. Okay, so let me give you an example. First of all, start off by providing me with an interpretation according to which this sentence here is true. Pause now. Okay, so hopefully you came up with an example, with a solution that looks like this. Okay, so you notice that you've got a conjunction, so you've got to make the left conjunct true, and you've got to make the right conjunct true. So far, so good. However, this was left blank. And that does create a problem, because if your professor comes along and says, oh, you're saying any interpretation like this makes this sentence true, what about an interpretation like this? So it's got these two, but it's also got this guy here. Well, now you've got a problem, and I call it a problem of failed correspondence, or I would say that this identity tableau exhibits failed correspondence, meaning it violates the laws of identity in some way. I'm going to tell you how so in a second, but I want to give you a chance to pause and see if you can figure it out for yourself. What's wrong with this? Okay, hope you've had a chance to figure it out, but if A is identical with B, then it cannot be the case that A has the property F and B does not have the property F, right? If A is identical with B, right, then they either both have to be F or they both have to lack F. So it would have to be like this, right? Or, you know, if they were both like this, that would no longer have failed correspondence, so it would be okay in that sense, but it would no longer be making this sentence true. So if we're trying to make that sentence true, you're going to have a plus in both columns, because, you know, if A is B, then it can't be that A is red and B is not red, right? If Spider-Man is Peter Parker, right, and Spider-Man can climb on walls, then it's better be the case that Peter Parker can climb on walls, right? So this is something we'll be able to prove about identity in chapter 6, so stay tuned for that. But that's one way in which an identity tableau can exhibit failed correspondence. So like if you were to leave this blank, or if you had the negative here, this would exhibit failed correspondence. If they're identical, then any property that A has, the thing it's identical with, namely B, is going to have that property as well. Okay, so like I said, there's different ways you could fix it, but you want to fix it in a way that still gives you the desired result, in this case of its being true. You could also, you know, have opposites here. If this were negative, okay, that would be fine, but it would no longer be making this sentence true, right? So this does not exhibit failed correspondence because they're different things. So A can be red and B not red, right? But if A is not identical with B, this sentence is false. So if we're trying to make that sentence true, you have to have the true here, and that forces things to look like this. Otherwise, it's going to exhibit failed correspondence or make the sentence false. Okay, let's spill into the next video on 5.4b, and we'll keep discussing this.